Good evening all, and once again I welcome you all to the live session, week 4 problem solving session for NPTEL course Advanced Concrete Technology. I'm Nilakanmani. I'm a PhD student from IIT Madras. I'm doing my PhD in construction materials. We can see some problems from week 4 content, and I expect you guys watched the videos from week 4. And if you have watched, then it will be easy for you guys to solve the problems we discuss in this class. In last class, you guys have asked me to explain the problems regarding cement chemistry. Cement chemistry problems, there are two problems in which we discuss how to quantify the hydration products and how much gel water can be present in particular water to cement ratio. So that problem I'll be discussing the second problem discussed in the class, discussed in the NPTEL video. So in the first question, water cement ratio was 0.5 and sufficient water was there for the cement for hydration, and the way how the problem was solved was different. But for the second case, where the water to cement ratio is 0.3, so there will not be sufficient water for the cement to hydrate. So then there will be a problem because sufficient water is not available for the cement to hydrate. Okay, so that we assume that if 100 grams of cement is given and 30 grams of water is there, we assume that only 3 grams of cement hydrates. Okay, so the first thing is, do you know what is mean by solid hydration product and total hydration product? Can someone unmute and say what is the difference? If you want to calculate the hydration products, generally we sum up the amount of cement with water to calculate the total hydration product and reduce some amount for the shrinkage. Can someone differentiate what is the difference between um, total hydration product and solid hydration product? Okay. The difference is, in solid hydration product we do not include the gel water content, but in total hydration product we include the gel water content. Okay, so uh, in this given condition, the total amount of cement given is 100 gram and the water is 30 gram. Is it the water is really sufficient for hydration? I do not hear any response from class today. Am I audible?
Yeah, ma'am, audible.
Okay. So how to calculate the solid hydration product? Means, so we assume that only p grams of cement hydrate. So let me change the pointer. Okay. So we assume that only p grams of cement hydrates, because we need about 23 grams. If 100 grams of cement is there, 23 grams of water is alone needed for the bound water content, which will be chemically bound to the hydration products. And addition to that, we need some gel water, which normally will be added to the uh, cementitious products. Okay, so we need some, if some water is present, obviously it will be attached, some amount of water will be used for the formation of hydration products, and some amount of water will be available as gel water. Okay, so first we'll see how to calculate the solid hydration product, which is explained in the class as well, in the NPTEL video. So we assume only p grams of cement hydrates because sufficient water is not there. We need at least 42 grams of water for complete hydration to happen. At least 42 grams. Okay. So now to calculate the solid hydration products, we assume that only p grams of cement hydrates, and we convert the grams into volume. Okay, for understanding purpose, and then So P, what is the density of cement, which is nothing but 3.15. So we divide the grams by density to convert it into volume, and we know that whatever cement is present, about 0.23 grams of water will be present as bound water. So we assume that 0.23 into P amount of bound water will be present, and there will be a certain amount of shrinkage, right? So this is the cement, and this is the water, bound water, and from that we are going to uh, subtract the amount of shrinkage that will be happening due to the reaction, chemical reaction. Okay, so there will the which is nothing but 25.4 percentage of the bound water is a shrinkage. So 0.254 multiplied by 0.23p is nothing but the shrinkage. Okay, so once we sum it up all these things, we get 0.489 times of p as the amount of solid hydration products, which does not include the gel water and capillary water. Okay, now we have to calculate the remaining parts. How to calculate the porosity? We all know that gel porosity is about 0.28% in this when cement hydrates. Okay, so from that we assume that the porosity is 0.28, which is nothing but 28%. Gel porosity is nothing but the amount of volume of gel pores divided by total hydration products, which is nothing but the summation of solid hydration products and the gel water. Okay, so uh, from this this equation is directly given, and sir has said as how if we solve equation 1 and 2, but I've just rewrite this equation as below. So what we do is we take this denominator part to the left side, which occurs as 0.28 multiplied by the 0.489p plus v gel water, if we take it to the other side. Okay, and then we have only gel water this side, and we multiply this 0.28 into 0.489p, which comes up as 0.1369 something. So I've written as 0.137p plus 0.28 v volume of gel pores is equal to volume of gel pores, which is already existing here, and I take this gel pores to this side. Okay, so what it happens is 0.28 minus 1. Okay, so this will be same as it is 0.137p minus 0.72 volume of gel pores. Okay, and the second equation is, we know that the total water is 30 ml. Okay, so the amount of water already exists will be present as, since what we assume here is there is no capillary water, there is no sufficient water for the capillary waters to fill the capillary pores, because we know that we need at least 42 grams of water for complete hydration, which will be present in the total hydration which will be present in the as bound water as well as the gel pores. Okay, which will be present. But if 42 grams of water is not there, then there will be not be sufficient water to fill in the capillary pores as well. So we assume that the total water is 30 ml, which is equal which is 30, which will be equal to the bound water, which is 0.23p, which is p is nothing but the amount of cement hydrates plus the volume of gel pores. Okay, we eliminate the term we volume of capillary pores. Okay, we have to solve this two equation. Just assume this is x plus y is equal to one term, and then x plus y is equal to another term, two algebraic equations. Okay, now you can solve this equation, right? In calculator you can easily solve, right? Or else manually also you can solve, but it will take some time. I cannot hear anything from class today. Is everyone available? Are you guys able to follow today? So let me open the chat box first. Okay. As per the rule, we are not supposed to discuss grading assignments. Okay, which are subject to the grading. We are not supposed to discuss. So maybe I can explain the technical part but not the answer. That is not possible. KPC Rao, right? We have been instructed not to discuss the grading assignments. Okay, please
Ma'am,
mail in the discussion forum. Okay.
actually, the assignments have been submitted and the grading has already been carried out.
Okay.
But the confusion is like, for example, I have written calorimeter. The answer says colorimeter. So that kind of 2 3 doubts are there, ma'am. And in one of the assignment, I wrote as the crystals as hexagonal crystal. Now the software what you have fed, they want the exact nomenclature of hexagon. I wrote large hexagon, so it didn't accept it. It is again minus negative marks for me there.
Okay. Please write your query to a query in the discussion forum. Okay.
Now, how to reach this discussion forum, ma'am? That was another question because I'm logging in, and after
Mhm.
that, I can see all other queries, but I'm not able to type my own query, ma'am.
Okay. Let me show you. I think you guys are able to see my screen. So once you go to NPTEL website and once you reach your courses, right? And here ask a question is there, right?
Okay, ma'am.
Once you reach that, here there is an option called new conversation. If you click that, you can uh, you can put your question.
Okay, ma'am. I'll try it out because this icon was not reflecting in my mail, ma'am. I'll just try it out.
Okay. You have to log into NPTEL website. From that, in the course page, ask a question will be there. From that, you can raise a question. Okay.
Ma'am, I'll do that.
Okay. Thank you. Are you guys able to follow the class? Okay, I'm not hearing any yes or no. Okay, fine. So, as explained, once we form these two equations, we can solve them easily. So, once if we solve these two equations, we'll get what is the amount of cement that will hydrate and then the volume of gel pores. Okay. So, once we know that, we'll be able to calculate the amount of solid HCP, which is nothing but volume of solid addition product will be nothing but 0.489 P. This P I have already found out, 71.5. So, that will be not such. So, the volume of how to calculate the volume of total addition products, which is nothing but amount of cement hydrates 0.49 into P plus the gel water, which is nothing but the total addition products. Okay. So once we calculate the total addition products, and then we have to calculate what is the amount of unhydrated cement product, because here we know that some percentage of cement does not hydrates, right? Which is nothing, it's very easy. 100 minus this 71.5, which is nothing but uh, which will be around 20, which will be around 28, I suppose. Or then you have to divide it by specific gravity of cement to get it as a volume. Okay, which is nothing but 9.1 ml. And then uh, how to calculate the capillary force present. But you have to understand that the capillary force will not be with water. Okay, so how to calculate that? Uh, First, we have to divide the total amount of cement by the total amount of cement is 100 gram, which will be divided by 3.15 to get us volume, and plus the volume of water here. If it is done, then we have to include the total amount of hydration products, number 48.5, plus the amount of unhydrated cement. So this total hydration products will include, sorry, I have not used pointer here, so you guys are not able to follow the class. So this total hydration products, which it will include both the solid hydration products as well as the gel water, gel pores, and then from that we are also including the volume of unhydrated cement products. Okay, So that will be here. So which is nothing but 4.2 ml will be present as capillary force. Okay. So this is how we have to. I guess you guys have know how does you guys are not able to follow how to solve these equations, right? Because it was given as such. So you have to just rewrite the equation, then you have to solve. Okay. I hope you guys got it, and I am not able to
Ma'am,
already
I
type.
have another process
Yeah.
to solve this. I have found it.
Okay. Are you able to get the answer?
Nice.
Are you able to get the answer by solving in the way how you found it out? Hello, hello.
Yes, ma'am. Sure.
Yeah, you can speak.
Yes.
If you're able
Yes.
to solve the problem in your way, then it's fine. But the answer
Yes.
should
Yes.
be right. Okay. Make sure
Yeah.
that's working. Okay. Let me move to problem solving session for week 4 content. Okay. So this is the first question. This time I've not loaded the questions in polls part because most of the questions are with multiple options. So polls, it will not work for multiple options. So I've given most of you guys have to type the answer in the chat box. Okay. So moving to the first question, you have to pick up the false statements. Here there are totally 5 statements, but you guys have to pick up the wrong statements. Okay. Just I'll read through the 5 statements and I'll give hint which is right or wrong. So yeah, you guys have to find it which are the wrong statements. Okay. First statement is aggregate does not play any part in controlling the dimensional stability of concrete. Okay. So you guys know that more than 70% of the concrete is made up of aggregates. 60 to 70% of concrete is made of aggregate. So you know that aggregate is an inert part, non-reactive. So what do you think? Will it not play any role in dimensional stability of concrete? Just think it, okay. And the porosity of aggregates is the only factor governing the water content and the mixed proportion. So you know the water to cement ratio generally how we decide based on the cement content, and if there is some we have also calculate amount of water required for attaining uh, uh, like we also we'll calculate the water absorption content for aggregates, and then we add that also to the water to cement ratio. So just think here the statement given is porosity of aggregates is the only factor governing the water content in mixed proportion. Okay. And the third statement is aggregate with the rough surface will give better bonding with the binder. Okay, just compare a smooth surface and a rough surface. Which surface will have a better bonding? Okay, and then the fourth statement is the discrete nature of ITZ. ITZ in high strength concrete leads to ductile failure of concrete. Okay, here just don't think about ITZ. Just also think about high strength concrete. Uh, like which type of failure mechanism will be there in high strength concrete? Will it pass around the concrete to the ITZ, or it will pass through the aggregate? Okay, just think. And so the discrete nature of ITZ in high strength concrete leads to ductile failure of concrete. Okay, and the fifth statement is because of bleeding of water there is less anhydrous cement near surface of aggregate than at bulk. Okay, yes, they are saying bleeding of water is the reason for this. Yeah, here you guys should not pick up the right statement. You have to pick up the wrong statements. Okay. Let me wait for 1 minute. Now this time is 6:20. Let me wait till 6:21, and please post your answers in chat box. Which options are right? In between, if you guys are not able to understand the question I posed, you can unmute and ask. 1 minute over. Shall we stop sharing the screen? Or does anyone still wants me to share the screen? Okay, let me stop sharing the screen. Okay. BD. Okay. BD. ABD of Fox. So there is some mixed response from the class. Let's see what are the wrong statements. Amar Ahmed Khan has raised his hand. Any query from your side, Amar Khan? Okay. Let's see what's the answer. So the correct answer is ABD. I don't think people have said BD and BDE, but not exactly ABD, I suppose. So moving to the first option, aggregate does not play any part in controlling the dimensional stability, which is not true because aggregates play the main role in dimensional stability because cement on reacting with water, it shrinks. So aggregate plays a major role in dimensional stability. Okay, so that is false. And the second option is porosity of aggregates is the only factor governing the water content and mix proportion. That is not true because we add the water to react with cement. Okay, so the amount of cement in the system mainly governs the water content. And then we add some more water because aggregates will readily absorb some water based on its absorption percentage. Okay, then so option D is ruled out, and then it's false. And then option C is aggregate with smooth surface will not give better bonding. Aggregate with rough surface only will give better bonding. And then option D is the discrete nature of ITZ in high strength concrete leads to ductile failure. High strength concrete does not fail in in the ductile failure manner. Okay, so that is also wrong because the failure plane goes through the aggregate and not through ITZ in high strength concrete because we are reducing the homogeneity. So in high strength concrete by densifying the matrix, so which is not true. Okay. So now let's move to question two. Question two is a to match the following kind of question. So here you have to match the uh, uh, mineral type with its rock, and then only for this thing alkali carbonate. Okay. Most of the case it's like that only. You have to match it with its mineral, and only in this for F it's alkali carbonate reaction. Which rock will have alkali carbonate reaction? You have to match that. In other cases, mostly you have to match it with the mineral type with the rock. Which mineral will be present in which rock? Okay, and you have also to match the uh, type of mineral present in a particular type of rock type also. Let me start timer for a minute. After a minute we'll see the answers. In the meantime, if you guys have any doubt, if you guys are not able to understand the question, you can unmute yourself and ask. Shall we stop sharing the screen, or is still someone answering? stop sharing the screen. Only two of them have given answer. You guys need some more time? Okay, we don't have enough time, so let me share the solution now. Let's see whether you guys have given the right answer. Yeah, you guys have given the right answer. Sorry.
Ma'am, a small doubt, ma'am.
Yeah.
Ma'am, in the earlier class, ma'am, there was one thing which was taught that as per IS code, ma'am, 25% of the recycled aggregate can be utilized as per the new norms, ma'am, as per the new IS code.
Okay.
Ma'am, in earlier classes, we were told that the hydration process is a long-going process, and if water is not reaching to few of the unhydrated particles or any of the, we can say the chemical elements inside the concrete, they don't react and they stay like that only, ma'am.
Sorry, I'm not able to follow your question. Can you repeat it again?
Ma'am, what I'm trying to bring out is the hydration process is a long process, ma'am. It goes on continuously.
Okay.
And if water is not available, enough water is not available, so some particles are left unhydrated inside the cement, in the concrete, ma'am.
Yeah.
So when we take this recycle aggregate, won't these particles have those unhydrated or unattended particles react with water again in the new combination, this thing, ma'am, and cause something else also? Is that possible?
So, see, if you think about recycled aggregate, probably it will can think it has already served in the structure for more than 30 to 40 years. Okay, at least 20 years, right?
Yes, ma'am.
So when you think about old structures, probably the water to cement ratio will not be that higher. Okay. Recently, only we are reducing the water to cement ratio less than 0.5. Before it used to be 0.5 to 0.6 in the range. Okay. So when you have enough water for hydration, and if you leaving for that long time, the amount of fraction left unhydrated will be very less. And you have to think, if it's a recycled aggregate, then concrete, then obviously it will have, if the fraction is not reacted with water, then obviously it has more chances for carbonation as well.
Okay, ma'am. And how about these other elements like, ma'am, at that time the sand will also be there. Then the
Yeah,
C3A, C3AF
it
will
will.
be also be there, some these components.
Sorry, C3A. What is that?
Ma'am, tricalcium aluminate, if some elements are left out, ma'am, they might not participated in the
See,
hydration.
just think about the fraction left unreacted. How much will be there?
It will be very less, ma'am.
Very less, yeah.
But again, if those elements are combining with the new hydration process, will it affect or not, ma'am? That's in my query.
How it will affect? Because obviously the cement manufacturers are not totally going to change or play with new. Yes, even now it's going to be dicalcium silicate, tricalcium silicate, tricalcium aluminate, and tetracalcium aluminate. It's going to be the same. Anyway, the same type of products will be forming, and the amount of product left unreacted will be going to be very, very less, because it's an old structure. It has been served for more than 10 to 15 years at least, I suppose. And then the amount of water to cement ratio expected is, if you think it has been very less water to cement ratio, fractions left unreacted, then obviously there is more chance for it to carbonate also when while breaking the concrete. And it's the maybe if we expect more than 50% is left unreacted, that is not going to be happening in the real case. It's
Okay,
not
ma'am.
going to affect in a as in a the effect what you expect will not be there in the large scale. Okay.
Okay, ma'am.
Yeah. So now let's discuss the solution for this question. Uh, so feldspar is a type of mineral. Uh, so do you know which rock it is? Which rock it will be in which rock type it will be present? So it's present in orthoclase as per the option given here. So the correct answer is 1, 2D. So if it's a potassium based feldspar, then it's called orthoclase. Okay. So hydrosilica. Do you know opal is a type of hydrosilica, and then Chalcedon is a form of fibrous silica. Okay, so this is the right answer. So question 3, the correct option is option E. Hornblende is nothing but iron and magnesium silicates, and then 4 is C, because musquite is a type of a micaceous mineral. And then 5 I've already told, and dolomite is nothing but calcium carbonate type of mineral, so it will be subjected to alkali carbonate reaction. Okay, so this is the right answer. Let me move to question 3. Now you have to find which of the following statements are true. So there are 4 options. You have to pick up the statements which are true. Okay, let me read out the statements now. Calcite is nothing but calcium carbonate, is acid soluble, whereas quartz is not. Okay, so this is the first statement. Just think about whether calcium carbonate will be soluble in acid, and quartz means it's silica based rock type, which will be not soluble as per the statement. Do you think it's true? Okay, then option B is iron oxides are used for heavyweight aggregates. So in aggregate chapter, sir, I've taught you for what we use heavyweight, for what type of applications we use heavyweight aggregates, and then you have given some examples of heavyweight aggregates. Along with that, you have also explained what type of ores can also be used as heavyweight aggregates. If you know that, you can know whether the option is right or wrong. And option C is pumice and granite or pyroclastic igneous rocks. Which means pyroclastic igneous rocks means which is cooled down to the near earth surface. Okay, and chert and gravic or minerals which is present in this type of rock. Do you know chert and gravic or which type of minerals? It's whether it's a igneous type of mineral or sedimentary type of mineral or metamorphic type of rock mineral. Just think about it and then give your answer. Option D is andesite and rhyolite are prone to alkali silica reaction because of the presence of silica glass, that is reactive silica. Okay, now let me start the timer. Please pick only the right statements. This question is quite easier one as well. So please give your answer in the chat box. I request everyone to type your answers, please. I'm not going to read out your name. I'm just going to check whether what answers you guys have typed in. Time is up. Let me stop sharing the screen. Okay. A, B, 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 B. Only 5 to 6 people have given your answer. And there are around 22 people in the class. Chandrasekhara Heber. Chandrasekhara, do you have any doubt? You have raised your hand. Chandrasekhar? Okay. Let's see the answer for this question. So, the correct answer is ABD. I think 2 to 3 people have given the right answer. So, and 1 people have given a partial right answer. So, calcite is nothing but calcium carbonate, which is just readily soluble in acid. So, and you know that silica is not soluble in crystalline silica is not soluble in acid. Quartz is such type. So, option A is true. And then option B is, we know that iron ores are also used as heavyweight aggregates. Okay. So, option B is also true. And pumice and granite are pyroclastic igneous rocks. So pumice here is pyroclastic igneous rocks, which is, so when the lava comes uh, uh, from volcanic region. So when it is thrown out to the surface, when the rocks cool near surface, then it is called pyroclastic igneous rocks. And there will be some opening through the volcanic path, right? So if it gets entered to that space, and then if the magma cools down within the earth crust, then it is called intrusive igneous rocks. So granite is such type of rock which will cool down very slowly. So which will cool down very slowly, and it's not pyroclastic igneous rock type. Okay, so it's intrusive igneous rocks. Pumice is a type which is pyroclastic igneous rocks. They are very porous. Okay, compared to this, granite has the crystals are well defined in granite compared to this pumice type of rock. Okay, and the chert and igneous grave core minerals, they are not igneous rock minerals. Okay, they are sedimentary rock type of minerals, both chert as well as grave. Okay, so this statement is false. And coming to option D, andesite and rhyolite both are not substitute to use for construction purposes because it has reactive silica in it, which is prone to alkali silica reaction. When the cement has alkalis in it, free alkalis in it, and then this reactive silica can react with this alkali from the cement, so that that there will be formation of reaction products and expansion will be there. So we are not supposed to use andesite and rhyolite uh, for construction purposes. Okay. Hope you guys are following the class. So now next is the very easiest question. Uh, I want everyone to type the answer in chat box. Water can be reduced up to 5 to 8% using which type of water reducers, and by 15 to 25% by using which type of water reducers. There are three options totally: normal, normal range, mid range, and then high range. 5 to 8 water reduction. Let me start the timer for 1 minute. Please type your answers. I want everyone to type the answers because it's a very easy question. 5 to 8% of water reduction will be achieved with which type of water reducers? And then 15 to 25 amount of water reduction can be done with which type of water reducers? Is anyone still writing your answers in chat box, or should I stop screen? Should I stop sharing the screen? Okay, I suppose everyone has given their answers. Let's see. Okay, most people have given the right answer. Okay, thank you. Thank you for this response. I feel a bit happy now because I could not hear the normal sounds that I hear in the class time. Okay, the correct answer is nothing but option D. So up to 5 to 8% of water reduction is done with normal water reducers, and then 15 to 25% is achieved by high range water reducers. So mid range water reducers means 8 to 15% water reduction can be done with mid range water reducers. Okay. So now let's move to question 5. Now you have to pick the statements which are false. So you guys have to read all the statements and find out the wrong statements. Okay. I'll read the statements and explain it a little bit so that you guys are able to follow and give the answers. So option A is the water reducers can be used to reduce the quantity of cement by keeping the water to cement ratio constant. So it says that water reducers can be used to reduce the quantity of cement by keeping the water to cement ratio constant. Okay, this is option A. Generally, we think that water reducers can be used to reduce the water amount of water and we can increase the strength, but here the statement says it can be also used to reduce the quantity of cement by keeping the water to cement ratio constant. So they are saying that we can reduce the water content and as well as cement at the same time using water reducers, so that we'll be able to maintain the water to cement ratio constant. Okay, now let me move to option B. At high dosage of water reduces, the concrete may show excessive retardation and bleeding. So there is a particular dosage of water. There is a particular dosage for the given water reduces. Okay, plasticizers. So if we exceed the dosage and use higher dosages, concrete may show excessive retardation bleeding. Do you think so? It's false or right? Just think and give your answer. And here it says option C is sugar is a bad water reducer and accelerates the hydration process. You guys know that lignosulfonates is also kind of a sugar kind of uh, like it's similar to sugar molecules, lignosulfonates, and here they're saying that sugar is a bad water reducer. It says that it does not reduce water at all, and then they are saying that it accelerates the hydration process. I think sir has explained in class that sugar, what does it will happen if some truckload is used to add sugar to the concrete mix if there is some delay in the delivering the process, but it has a disadvantage because it will cause retardation. So I just told whatever explained in class as well. So just think what is about option C, whether it's true or false. Then option D is the mechanism of steric hindrance due to bulky side chains is experienced for lignosulfonates. So here they are saying that lignosulfonates has steric hindrance effect due to the bulky side chains. So just think lignosulfonates does belong to which type of water reducers? Does it belong to first generation, second generation, or third generation? And just think bulky side chains. Steric hindrance is present in which generation of water reduces. So I'll say that one clue, lignosulfonates belong to the first generation of water reducer. Just think and answer. And in SNF, dimers and trimers with low molecular weight cover reactive sites in cement and inhibit reactions causing retardation. So this is a statement. Just think SNF, there are 2 points which work better with SNF. One is sulfonate should be present in the beta portion, and the second point is we have to remove the low molecular weight SNS using centrifugal centrifugation process, so that it will work better. So just think that is the clue for option E and answer. Let me start the timer for a minute and then we'll see what you guys please type your answer in chat box. After a minute we'll discuss the answer. In the meantime, if you guys are not able to follow the class, please unmute and ask or else type in the chat box. Anyway, while before discussing the answer, I'll see the chat box. And I'm remembering once again, we have to pick up the false statements and not the correct statements. We have to pick up the statements which are wrong. Time is up. Let me stop sharing the screen. Okay. Okay. C and D are false. Okay. C, D, E. C, D, E, D, E. Okay. More C, D, E. Let's see what's the right answer. So the correct answer is C and D. It's not C, D, E. Most of the people have given you C, D, given the answer C, D. Okay, let's see what's the right answer. What is about D? Okay. Here option A says that water reducers can be used to reduce the quantity of cement by keeping the water cement ratio constant. Yeah, sir has explained you while introducing guys to the water admixtures and then water reducers. Sir have clearly explained you by keeping the water cement ratio constant, we can reduce the amount of cement used, which gives an economical solution as well by using water reducers. Okay. And at high dosage of water reduces, yeah, obviously there will be retardation as well as bleeding. So that is also true. And then coming to option C and D, C is like says that sugar is a bad water reducer and accelerates the hydration process, which is false. Sugar is a kind of water reducer. It's not a bad water reducer, but if you use it high dosages, it will cause air entrainment as well, and it will not accelerate hydration process. So it will cause retardation. And moving to option D, the mechanism of steric hindrance. So lignosulfanes belong to first generation of water reducers, and then um, carboxyl ethers belong to third generation of uh, third generation of water reducers, which has steric hindrance is the is the main mechanism. It has both absorption as well as repulsion mechanism, but steric hindrance is the main behavior, is the main mechanism of third generation water reducers. So obviously this option is wrong. C and D both are wrong. And coming to option E, drimers and trimers with low molecular weight cover reactive sites in cement. Okay. So which means low molecular weight uh, uh, SNFs generally cause retardation. So that's what the statement says, which is true. Dimers and trimers in the sense, so polymers in the sense it has a long chain polymer. Dimers and trimers means only two molecules of SNF, and then trimers means only three molecules of SNF together, which does not make us a polymer. So dimers and trimers are low weight SNFs, low molecular weight SNFs, so which will obviously cause retardation by covering the reactive sites. Okay, so that is also true. So the correct answer is CD and it's not CD. Okay, now let me move to next question. It's a match the following question. So here you have to, so the first question superplastizes, you have to see, uh, uh, you have to match it with its functions or uh, what is given in the right side. Okay, let me start timer for 2 minutes. So guys, I want you guys all to answer this question. SNF is nothing but sulfated naphthalene formaldehyde, and then PCE means polycarboxylate ether. Just match it with its properties or functions, and then long dispersibility retention, and then high dispersibility. Here I think they are discussing about PCE type of in which sir has discussed about its function with the long and short uh, backbone polymer and then side chain. Based on the length of the side chains and the length of the backbone polymer in polycarboxylate ether type of water reducers. Time is up. 2 minutes is over. Let me stop sharing the screen. I hope you guys are able to give the answer. Let's see the response now. Okay. The ADC, that is answer from 5 to 6 people in the class. Okay. Let's see the right answer. Okay. Most of you guys are given the right answer. That's good. So let's see. So let's see the expression part. So coming to superplasticizers, generally the dosage of superplasticizers is around 0.7 to 1% by weight of cement. Okay. So 1 is nothing for superplasticizers. The correct answer is 1B. Okay. For 2 is nothing but sulfated naphthalene formaldehyde. It's effective for both positive and negatively charged particles. Okay, because anyway it imparts negative charge for all the particles, so it gives repulsion. Um, uh, so obviously it works for both positive and negatively charged particles. And coming to PCE, uh, polycarboxylate ether, the correct answer is steric hindrance, because the working mechanism of polycarboxylate ether is steric hindrance. So PCE belong to which generation of water reducers? Can someone unmute and say?
Third generation.
Yeah, thank you. I'm really today I feel totally absent because I could not hear any noise from any voice, nothing from class. I feel that there is no one in the class today. Thank you for answering. Um, PZ, the working mechanism of PZ is nothing but steric hindrance. What is the working mechanism of SNF? Can anyone else tell?
Electrostatic repulsion.
Yeah, thank you. So coming to fourth and fifth, long dispersibility retention when it will occur, and high dispersibility when it will occur. So the left options are C and E. So relatively large number of side chains. So if there are large number of side chains, then there will be long dispersibility retention. And then if there is relatively small number of side chains, then there will be high dispersibility. Because if the number of side chains are more, then it will be difficult for it to disperse. So if there are relatively small number of side chains, there will be high dispersibility. Okay. So this is the answer. I'm moving to question 7. So question 7, you have to pick up the right statements. So you have to read all the options and you have to pick up the right statements. So let me read the statements for you. Coming to option A, poor slump retention is an indicator of good compatibility of superplasticizer and cement. So when you say it as a poor slump retention, if there is a good compatibility between superplasticizer and cement, do you say it as a poor slump retention? So if there is a good compatibility between SP and cement, how it will be indicated? Will there be poor slump retention as an indicator? Just think and answer. And then coming to option B, calcium sulfate, which is nothing but gypsum. The type of calcium sulfate, either it's going to be dihydrate or hemihydrate or anhydrate. Calcium sulfate affects the compatibility of superplasticizers. So, sir have discussed the type of calcium sulfate which will affect the compatibility of superplasticizers. So, sir have told you that combination of all the type of calcium sulfate, either it's dihydrate, hemihydrate, and anhydrate, is required for the cement to function properly while reacting with water. So just tell the type of calcium sulfate, will it affect the compatibility of superplasticizer? And then coming to fineness of cement, fineness of cement will retard adsorption of superplasticizer and increase the workability retention time. So here they're saying if cement is very fine, will it retard the adsorption of SPs and increase the workability retention time? If cement is very fine, just think about it. And then option D is the C3A tricalcium aluminate influences the compatibility of SNF superplasticizer. It gets adsorbed on C3A, leading to loss of slump and delayed setting. And there is a particular slide which discusses about the compatibility of SNF with C3A, type of C3A, it's reactive or non-reactive, availability of gypsum and both reactivity of C3 and availability of gypsum along with SNF compatibility. So if you have gone through that slide, then obviously you know the answer. Coming to option E, Marsh-Cohn test can be done to check the optimum dosage and compatibility of superplasticizer. Okay, so do you think Marsh-Cohn test is done for that? Then give your answer. You have to pick the right statements. Let me start timer for a minute. After a minute, we'll see the answers. And this is the last question for class today. So I request everyone to give your answers, please. It is going to be right or wrong. You'll get to know your, you'll get to how much you're able to understand, and you have to. If you're not able to understand, just ask question, or else you invest more time on reading, so that you'll know how much you can understand or not. If you're not able to understand, you're open here to ask questions, raise questions, and if the time here is not sufficient, even you can write your queries in the discussion forum as well. Okay, time is up. Let's see the class response and then discuss the answer. Okay, Mupil have given us B, D, E. Okay, most have said it's B, D is true. Let's see the right answer, whether it's right or wrong. Okay. So the correct answer is B, D. Most have given the right answer. So coming to option A, pore sump retention is indicator of good compatibility. So if there is a good compatibility between SP and cement, will there be pore sump retention? No, right? So which is a false statement. Then coming to option B, type of calcium sulfate affects the compatibility of superplasticizer. Yeah, that's true, because the type of calcium sulfate, it is going to be dihydrate or hemihydrate or anhydrate, will affect the compatibility of the superplasticizer. And then moving to option C, fineness of cement will retard absorption of SP and increase the workability retention time. So if the cement is very fine, obviously it will not increase the workability. That is a very easy way to find the statement is wrong. And then coming to option D, C3 influences the compatibility of SNF, and then it gets absorbed on C3, leading to loss of slump and delayed setting. Because both SNF as well as gypsum will fight for the C3A reactive site. So obviously we have to check for the compatibility of with C3 and SNF. So the option is correct. So option D is true. And then moving to option E, Marsh contest can be done to check the optimum dosage and compatibility of superplasticizer. That is also true. So here by this question 7, this is the last question for the session. So do you guys have any other doubt? Okay, thank you. Thank you, Harsha Gowda. Sorry, I know how. Let me call you Harsha. Thank you, Harsha. Thank you all for the. Thank you all for the patience, and today I could not hear much voices. Normally I hear from the class. I want everyone to be active participants so that I can also learn something from you if you guys have any query. Thank you. Okay, let me wind up the class here.